Hello, welcome. What I'm going to do for you right now is walk you through how to balance chemical equations. So first we need a sample equation to show you how to do this. The sample equation that we'll balance right now involves propane and the combustion of propane. Propane is C3H8. And when it's a combustion reaction, we'll add oxygen to that. So propane will react with oxygen gas to form or to yield carbon dioxide, CO2, and water, H2O. Now the point of balancing is to get the equation to follow the law of conservation of mass. Right now there's 3 carbons on the left-hand side, 1 carbon on the right, 8 hydrogens on the left, 2 on the right, and 2 oxygens on the left, but 2 plus 1, 3 oxygens over here on the right. So we need the quantities of each chemical to be the same on each side of our reaction. One of the very first things that I like to do is just put a visual barrier between the left and the right, so I always know that the stuff over here has to balance with the stuff over here. Now, when I'm balancing the equation, you can only add a whole propane molecule. You can't add just the carbons. You can't add just the carbons here in carbon dioxide. You couldn't add just 1 oxygen over here in the water molecule. You have to add in the whole water molecule, both hydrogen and oxygen, even if at the time you would only need oxygen. The only other rule, always and only, add to the side that has less. So let's get started. Always and only, add to the side that has less. Starting at the beginning, 3 carbons versus 1 carbon on the right. Always and only, add to the side that has less. We have to add in another carbon dioxide molecule. 3 carbons, 2 carbons. Always and only, add to the side that has less. Adding in another third carbon dioxide molecule gives me 1, 2, 3 carbons versus 3 carbons. So right now, carbons are balanced. Moving forward, you can see we have 8 hydrogens on the left, just 2 hydrogens on the right. This side has less, so we need to add there. Thing is, I can't just add H2, I have to add H2O, a whole nother water molecule. That gives me 2, 4, 6. One more gives me 8. 2, 4, 6, 8 hydrogens versus 8 hydrogens. Now hydrogens are balanced, carbons are balanced, 3s, and now what's left is oxygens. We have 2 oxygens on the left, 2, 4, 6, 7, 8, 9, 10 oxygens on the right. Always and only, add to the side that has less. Giving me 4, 6, 8, 10 oxygens. The last step in balancing this chemical equation is going to be to quantify how many units or how many molecules of everything I needed. I only needed 1 molecule of this. I needed 1, 2, 3, 4, 5 molecules of O2 gas. I needed 1, 2, 3 molecules of carbon dioxide gas. And I produced 4 molecules of water vapor. These leading numbers out here, those are called coefficients. Okay, coefficients. And the coefficient would essentially get distributed to everything in that section. So this is saying that I have 4 times 2, because it's distributed, 4 times 2, 8 hydrogens, and 4 times an imaginary 1, 4 oxygens. In this, we'd have 3 carbons and 6 oxygens, 5 times 2, 10 oxygens, 1 times 3, 3 carbons, 1 times 8, 8 hydrogens. Now my final answer, I'd write down here, I'd have C3H8 plus 5O2 yields 3 CO2 plus 4.
Good morning. The following teachers need to report upstairs to Ms. Davis's office for a parent-teacher conference, please. Mr. DeSigli, Ms. Bonilla, Ms. Bin, and Mr. Favali. Thank you.
My apologies for that. Plus 4 H2O. This is a balanced equation. And balanced equations follow the law of conservation of mass. And that's the whole point of balancing chemical equations, to get them to follow the law of conservation of mass. So hopefully this makes sense. Hopefully you are capable of balancing equations. Always and only add to the side that has less. Make sure you're adding in whole extra units. The dividing line is the yield sign. Thank you and have a great day.